Enterprise Computing HSC course Unit 3, Intelligent Systems. Now, in the previous units we've talked about data and the science behind it, how it's made up, how it's stored, and then how we use it, and how it's integral for decision-making processes. And then we moved on to then data visualization, how we can comprehend data in different ways and use graphical tools to extract more meaning out of data, simplifying it and making it easier for us as humans as well as audiences to understand. We're now moving into intelligent systems now, where now kind of the decisions being made, while still maybe supported by humans, are being made by the systems that we're using. So they are having very heavy input into the actions taking place within the system, automating processes, streamlining efficiency, and optimizing operations based on data gathered in relation to the system itself. So that's what we're going to be looking at here in the intelligent systems unit. So firstly, it's about the systems and their applications because we use systems in a variety of different contexts. And obviously, the second we can put intelligence into that context, the human element of those systems can be supported. So the first area is that of decision support systems. And as the name suggests, systems that support decision making. So it's used in a variety of fields, and I'll get to that in a moment. But these are a specific type or category of system that helps people make decisions. Now, the degree that the decisions can be made by the decision support system can be put into three categories: unstructured, semi structured, and fully structured, which ranges from the system can make all decisions itself, and they can be definite decisions, and it can actually do the processes once the decision is made, all the way to no, the decision can only make kind of estimates, and then a human needs to kind of go then ahead with it and say, this is the course of action we need to flow on with. So that's where decision support systems support the decision making process. Okay, obviously, it can have a structured set of rules that are fixed, and then a decision can be made, or it could be less structured, and there'll be human input in there, and they have to kind of then guide the decision making based on what the decision support system is saying. From here, we also have expert systems. So expert systems are systems that are focused on a specific area, a specific type of work, and obviously contain their own knowledge bases, and we refer to them for solving specific problems. So they might be used in medical fields to help with diagnosing specific diseases or illnesses people may have. But when we say diagnosis too, it could also be diagnosis for picking up on issues within a network. So helping us find out what is the cause of a problem and then thus helping us solve it. Also, they can be used for monitoring, seeing how a network is functioning and can it be done more efficiently, mapping out different pathways and routing data down different paths, and thus following on from that, helping control processes as well. Okay, managing energy, when different processes should run, when is it most efficient for them, and that could be done, and we might have seen that in the year 11 course in relation to irrigation systems on farms that actually tests when the soil is drier, and then those irrigation systems turn on, and then it puts water into the soil when they need it, supporting crops while also managing our resource management of water, which is a finite resources. And then flowing on from that, scheduling and planning. When is the right time to do things? So expert systems can support with all that based on existing data within the system, as well as gathered data from the environment and from the users themselves that are interacting with the expert system. Now, key features of the expert system, and I already mentioned one of them already, is that knowledge base. Okay, the knowledge base being the data source. These are the actions that can take place, and based on the conditions, certain actions will occur. So, what classifies the conditions that will take place? So, we're giving the knowledge to the system to act as the knowledge base. It then looks for different conditions occurring, and then when certain values or metrics or standards are met, it will then complete a specific action. Now, the actions then refer to the inference engine, okay, making an inference on what it should do and having ideas about what tasks should be done. So they are obviously interacting with each other. And then on the user's end, we need a user interface that contains data visualizations within it, summarizing the data that has been gathered about the specific enterprise and the scenario where the system is being used, a user-friendly user interface where the user then can enter their own inputs to support the system and its processes and the overall operations. Then we have the advancements in expert systems, and obviously once again, and we talked about this in the previous unit as well, as technology has advanced, we now can do more. And obviously, we're in the AI age at the moment. So a lot of this technology supports that. So firstly is just processing power. We know NVIDIA are working on specific CPU chips that work with AI processing because it takes up and consumes a lot more resources. So that is a big way they're going, and the other chip manufacturers are following suit to increase processing power of our CPU chips to support these expert systems. Then there's also data availability. We are in the age of data. If the first two units showed us anything, it's about how much data is out there and that we now kind of need to summarize it and categorize it in order to make it more meaningful to our operations, and also where it's stored, whether it's locally or we can extract it from online sources, whether from our own online servers or from more public servers as well. But we have much more data available in this modern age. Hardware costs always reduce over time, while capacity and power often increase. Okay, they maintain a certain price point, but over the long term, at the current 3 terabyte hard drive that I'm thinking about buying now, in a year's time, should be cheaper, but it's likely that a 5 terabyte hard drive will be out there too. So technology gets cheaper, but it's also continually expanding and maintaining the higher price points for the top end technology that we might need. We also have this thing known as neural networks, and this works in conjunction with knowledge bases in that systems, and once again AI, can develop its own connections between data and then start to create their own hypotheses and learning, okay, which is extremely powerful for artificial intelligence to learn about operations and make its own ideas and responses for given scenarios. And then we also have webometrics too, where we're interacting with the internet and it's integrated part of influencing how decisions are being made there for expert systems. So a lot of this stuff right here is happening right now live in this AI age, which makes it incredibly exciting. The next point is then proliferation of expert systems, its integration with these modern technologies. So, as said, with the Internet of Things, how the devices interact with each other and the flow of data within networks, and then specific endpoint devices, not just those that we use to view data like our monitors and computers and all that, but also with sensor devices as well. The role expert systems play in that it can read data from a sensor, its controller will interpret it, and then it'll use an actuator to make an output. Okay, all without human input. A whole operation can take place just with a computer through the Internet of Things, where we can focus on assembly line manufacturers or, once again, farms and their irrigation and operate them remotely with the system doing the bulk of the work and humans pretty much being there as supervisors. Also in the context of Internet of Me, because remember, we want each user to have their own individual user experience when interacting with systems. So based on what people are doing on social media or searching up on Google or what platforms they interact with, uh, these systems are targeting specific types of apps or recommending specific types of product, specific types of media, focused on what the current user is doing and giving them the best possible experience. And then also this idea of Industry 4.0. This is in line with the idea of the Industrial Revolution, how that came along and machinery within actual workplaces changed everything in the realm of manufacturing. We had machines doing operations. We then had waves of this again with Internet 2.0 and 3.0, with the coming of the internet and then following on the coming of social media, how that changed the landscape of how work was done, in that we now have online markets and shops to go with. So this Internet 4.0 is how now we kind of this AI age coming and automation coming, and that's the next wave of industry that we are currently on the verge of at the moment. So obviously there's a lot of change coming in the future, and we can already see the seeds of that with AI and robotics and the rate they're developing at. The next area is then the techniques of inference engines. So how do they kind of make their decisions and what are they based on? So we've got things such as truth maintenance, hypothetical reasoning, heuristic knowledge, fuzzy logic, and ontological classification. Okay, all of these areas are used, and I'm still learning about these components specifically at the moment. So I'm not going to go into too much detail there. There'll be a future video on that. Okay, then we've got specific hardware for intelligent systems. Okay, things such as biometrics, which scan obviously biological data of individuals for granting them access. Okay, and This could even be for a home network, okay, and how people engage with the home network on their own systems as well, okay, so that systems can read biological data from individuals. Haptic responses, where you might have it where you've got an iWatch or even a VR headset, and you actually get those vibrational outputs from the system, kind of confirming that a certain process has been registered by the system and giving you feedback with that vibrational data. Touch and gesture inputs, which have been a mainstay of mobile devices, okay, where we can use multiple fingers and gestures, okay, in order to give commands to a system. Virtual reality and augmented reality, okay, both of them, which are now becoming contemporary technology now, where we're using headsets, okay, or at least some sort of visor that we're looking into the world. With virtual reality, fully digital worlds we're looking into. With augmented reality, we're applying digital skins, overlaying it over real world information. All right, but ways we can look into virtual environments and augmented environments, which could become a part of our workplaces very soon. Okay, we've got the use of voice and sound within intelligent systems. Okay, now when you talk to your AI, it doesn't just have to be text on the screen. You can get things like ChatGPT to talk back to you and actually have a conversation with you, making it more powerful to people who reading isn't their strength. I'm one of those people. That's what's got me making YouTube, because I know that about certain learners. They don't always learn from reading. So kind of that visual stimulus, and well, in this case, audio stimulus, okay, that can be used to have a conversation in order to learn more from specific platforms. The importance of microcontrollers. Microcontrollers are the part of AI and robotic systems that register the data that has been obtained from sensors and make decisions based on that data, and then command actuators and motors to respond based on that input data. So microcontrollers are kind of the decision makers, and then, as in that final point, sensors, actuators, and motors all playing their role in collecting data through the sensor or acting out the data with the actuators and motors, and even sometimes end effectors as well, with those grippy arms and drills and all of that. The next point is computational thinking. So thinking like a system, like a computer. Okay, and there's a variety of steps related to this. So the first one is decomposition, which means breaking a problem down into its sub-problems, and thus, as a computer would think, into a variety of sub-programs. And we address them all individually and then bring them all together to make a larger system. We also have pattern recognition, so identifying patterns within environmental data, sensors picking up on patterns, and how a system responds based on specific patterns being recognized. We have abstraction, which relates to referring to data sources for the decision making process, okay? Pulling in data from a variety of different locations in order to make decisions. And then finally, we got algorithms, which we'll come back to a bit later, but obviously developing step by step procedures for solving a problem, traditionally done through pseudocode and flowcharts. But I think the only focus in our area here in enterprise computer is in that of specifically flowcharts. Okay, we've got issues with emerging technology, and obviously this is a very current area at the moment, particularly with AI and the things it can do. What is AI teaching us? The dependency on AI, okay, those kind of impacts there, and then how people can potentially not just use AI, but all technology can be used for negative aspects as well. And then stemming from that, how there's disruptive effects to technology too, and this kind of overlaps with issues with disruptive effects in the area of changing nature of work. Okay, workplaces will change. People might lose their jobs, or their jobs could change as a result of it. They have to lose new skills, okay, or their skills could become redundant. So there's a lot of disruptive effects with technology, okay, and the landscape of workplaces. And we are trying to balance out resources, environmental resources, financial resources, human resources, and the disruptive effects can go across all of them in relation to modern workplaces and where we're going in the future. And then finally, in this section, we've got specific types of diagrams. Flowcharts, as mentioned, for representing algorithms. We've got data flow diagrams for representing systems and their processes, and how external entities interact with these processes, and how the data flows between processes and information is given back to those external entities. And then infographics, using graphics to represent and provide data visualizations, which I guess all three of them are there, okay, on how certain systems are functioning or representing data in meaningful ways to users. So obviously, this is a big portion. The systems and their applications, a big portion of this intelligent systems unit. The next area is that of data and intelligent systems. And obviously, data being the foundation. We've learned that from the first unit in specific with data science, that it is kind of the foundation for the decision making process. And intelligent systems need to refer to this data. So, firstly, we have what do we do with surplus data? Where does it go? How do we know what is the surplus data? Where do we send it? Because unfortunately, one of our big issues at the moment is our storage capacities. Okay, storage is finite when locally on our own systems, when on servers, and even when we're using cloud servers. And yes, we can expand storage, but it comes at a cost. So we've got to think what we do with surplus data. Secondly, is the IoT infrastructure requirements. And I've already just mentioned a few of these just then in relation to surplus data. So we can have our own servers for our own local networks, which we have full control and access to and have great security, but we can't usually access them when we're not on site, which then brings us to cloud storage. Cloud storage having online platforms that have their own storage or using infrastructure as a service to provide us with online storage so that then we can work more globally and across metropolitan areas, being able to work remotely and from home. And then I also mentioned local storage before, the actual storage on the system you're using. The third point then relates to endpoint devices, the devices that allow us to interact with networks or output information from the networks. So input devices, you might be looking at my video right now and you are using a device such as a desktop computer, a laptop, or your mobile phone. They are all endpoint devices that have allowed you to connect to a network, most likely the internet, okay, and that's how you are viewing the data from the network on your endpoint device. And then finally, we have to develop communication links to actually structure our network so that data can be moved around the network between our nodes, our central nodes, and our endpoint devices. The next point is then of simulation, data modeling, and automation. So obviously, the things that it can allow us, once again, with either prediction, experimentation, or the system doing things on their own. And this is used in a variety of areas. One such being education and training, and particular simulation. Okay, so people can learn in controlled environments, such as in flight simulation. In business analytics, in the financial world, they'd be taking really big advantage of data modeling. Okay, what will happen if we invest in a specific area? How is the stock market looking? What is the best way to make money in a certain industry? Okay, and then obviously we have high risk applications too. So in environments where there might be chemicals or highly dangerous environments, okay, that have dangerous machinery. Well, if we can use automation in those environments, that keeps humans out of those dangerous scenarios, and they could be having their input from behind a screen in a completely separate area of an actual workplace. So supporting those high risk applications. So obviously they're not the only examples of those three different areas there, but they're just some simple ones that might help you with your understanding there too. Okay, we then have intelligent systems being used in conjunction with surveillance, okay, being used with security technology. So CCTV, which is used in public for monitoring public environments and keeping people safe in specific parts of environments. Biometric data, again, the recognition, facial recognition software for identifying people. Loyalty schemes for allowing people to sign up to things and having them registered, making them want to be registered as a part of specific programs. Fraud prevention by making systems, once again linking back to things like biometric data and having really strong credentials, makes it harder for people to pretend to be people that they are not, so thus presenting fraud. And then obviously sniffing and trolling for tracking out malicious entities within online environments too, or local environments as well through surveillance. And then the final point of this subsection here is that of artificial intelligence and the Internet of Things. The idea that artificial intelligence can be used in the Internet of Things and once again optimize the flow of data. Okay, finding the correct pathways that where data will move the quickest, finding out how to utilize nodes in the best possible ways, changing settings, and really supporting users within an Internet of Things. But then once again, going back to those other different technologies as well that can be used in Internet of Things, microcontrollers, sensors, and actuators, so that we're not just talking about setting up a network, we're talking about setting up an automated network where operations can be collect data. That data can be picked up by the actual Internet of Things and sent to some sort of centralized controller. That controller can make a decision and then make endpoint devices that are connected to the automated network then act out actions such as, yes, turning on sprinklers in an irrigation system or starting equipment within a hazardous environment or on an assembly line. So that whole larger interaction, but the thinking is done by the AI interacting with an Internet of Things. That's how the modern world is looking at the moment. The final section is then creating an intelligent system. Okay, and so we're kind of bringing all this together now to model a system here. So this may involve, firstly, developing rules and facts, and this is then thus creating our own version of a knowledge base that is built on specific rules and facts that need to be followed in order for the intelligent system to operate. We then have certainty factors and decision trees. So using a decision tree to map out combinations of conditions, and by mapping them out and stringing them together, certain combinations of conditions will then lead to certain actions taking place. And those actions would be the output of a system. So we map them using decision trees, and that could be used as a part of an assignment in this topic as well. We need to verify data sources. So where is data coming from? Is it from authenticated sources? So there's a security factor there, but then also reliable data sources and cross-referencing and ensuring that data is of a correct nature. Going back to flowcharts, using if-then rules. If-then rules, okay, the use of those keywords, they can represent different control structures. The two main ones that are, well, there are three control structures: sequence, selection, and repetition. So we can use if-then rules to represent both binary and multi-way selection, okay, as well as show as well different forms of repetition that might occur within a system, okay, when we need certain operations to take place over and over again, or with selection when decisions need to be made within our systems. We then have to design some sort of automated system. Design being the key word there, okay, mapping out, showing an algorithm of how a system could potentially work and really illustrating that logic, okay, and that might be how it's actually represented in an exam. So we do have to have some sort of algorithmic knowledge, and it might just be in the form of representing that in a flowchart. But if we are talking about if-then statements, could mean we have to know a bit of pseudocode as well. Okay, and then we need to assess DSS output because, as the name suggests, it's a decision support system. It supports our decisions. So we see an output from a DSS and then we interpret what action should take place as a human. But as said, with more powerful expert systems, there are systems that are fully independent of human interaction and they'll make decisions of their own. So that is common in the modern enterprise system as well. And then finally, we have expert systems contribution to efficiency. So a variety of technologies here, such as supercomputers. There's supercomputers in the world that they've spent millions of dollars on for doing things such as a weather prediction and trying to predict a whole variety of different things using large amounts of big data and historical data to make as much prediction as they can for the success of either human beings themselves and their ways of living, or in relation to financial markets and predicting the future. So expert systems help with that because they help with that decision making process with their rule sets, with their neural networks, with their knowledge bases and all of that. And yes, the systems act as a digital assistant. It's almost like you've got a person there supporting you with all that. And I'm sure we've all felt that when we use AI and we're either having a text-based conversation or a voice-based conversation with AI, you're talking to someone who's almost like a virtual employee that you can run ideas against and really refine what you're talking about to get an appropriate output from the system. The other big step that's kind of happening at the moment is autonomous vehicles. There are starting to be videos online of autonomous taxis that are moving people around in certain countries in low traffic environments, okay, without the need for a driver. The system takes people from point A to point B. But obviously there's challenges there because they're also interacting with human-based cars as well. And obviously there's a lot of variables to driving on a road and a lot of hazards and dangers around that these vehicles need to prepare for. It's also happening with trucks as well, moving products interstate, going up and down highways. Once again, low traffic environments, but then covering much wider distances without the need for a driver there. And there are also safety factors there too, because drivers can get tired, but a robotic or artificial intelligent based driver doesn't get tired. So there's those factors that actually support autonomous vehicles as well. So in the long term, that could work really good too. And then finally, with streaming services, how we get recommended things that the systems think they will like, and this helps platforms and enterprise systems grow their audiences. And I'm sure we've all actually experienced that one already with the platforms we interact with. So I hope this video is giving you an understanding of intelligent systems. These systems that are using all the data we've been talking about in the data science unit, and then as well as with the data visualizations for computers to comprehend. We have different types of intelligent systems, our decision support systems, our expert systems, which help users with their decision making processes using gathered data. These systems can become fully automated, where the actual technology makes full decisions themselves, and through the use of microcontrollers and actuators can act on the data. It can also interact with the Internet of Things, okay, to gather data from networks from a wider location and make decisions in that aspects as well. But what we're really having here is, yes, systems that are intelligent. They make decisions with the gathered data for enterprises and then actually act on that data, whether supporting humans with the decision making process or on their own. So, this is how enterprises are going. This is how the future is looking. As we said, we're on the verge of Industry 4.0, how the landscape of the enterprise is changing, where artificial intelligence and robotics are foundations of the actual technology of the enterprise, and that supports the decision making of the enterprise, hopefully leading them to success and a brighter future through establishing the technologies in their workplace.